Hello everyone, and welcome to the 9th video. In this video we're going to be talking about something called tracking problems, which is similar to one of the homeworks. I think it's homework 2, maybe? I guess we could actually go look. Why don't we make sure we're in the right spot? We're talking about the right homework. Perhaps there's some problems in homework 2 that are like this. I think that's the deal. Okay, so we're going to just go through 2 problems in this video, so it shouldn't be too long, and how to do them. For a lot of these types of problems, they're going to be pretty easy to find the answers. If they're written in a Word document, you could always just type them into a Python script, and then you run it, and then boom. You use some print statements and you've got your answers. In fact, with print statements, you can use commas to separate variables, and it'll just print with a space between each of these variables. So pretty easy to do in one single step. So the point is really not to get the answers, it's to show how you got those answers. That's what I'm looking for problems on the homework. That's what I'll be looking for any future quizzes or tests, which we'll do once I come back. So let's take a look at these problems. We'll be using all of our different operators, the arithmetic operators and the assignment operators in this video. So in the first problem, we have 3 variables, a, b, and c. A set to 1, b is 2, c is 3. And we're doing a bunch of different math to the values of these variables. The best way to go through these problems is to essentially annotate as we go. We are going to write out step by step how the values are changing, how things are simplifying, just like you would in a math class. The math here is generally going to be pretty simple. However, just because it's simple does not mean that you're going to easily get the correct answer. In fact, these problems are notorious for having many students get wrong answers, even though you all know how to do addition, subtraction, multiplication, division, using exponents, and now modulus. Granted, modulus is a bit newer. So what's the deal? Why do people get these problems wrong? And the answer is quite simply, you're going to be more likely to get something wrong if you're skipping steps. There's a great temptation to do things in your head to speed up the process by doing multiple things at once, and so on. But we have to be very careful that we don't do that, and we have to be careful that we're using the correct number as they're updated. Right after we run this line at line 6, the value of a is going to be different than 1, where we will have changed its value to something else. So that means when we get to line 8 here, we need to be using a different value for a. So let's begin this process. I'm going to have a few recommendations. So we'll list these here. Oops, I guess we should put this in a comment. Recommendation. Maybe we should do a multi-line comment. All right, number 1. Anytime you see a shortcut assignment operator, we're talking about these guys. I don't really want to write out all of them, but oh, etc. We got 2 more: modulus equals and exponent equals. If you see those, always rewrite the line using the equals operator and the appropriate, well, I guess we'll just say and parentheses surrounding the right hand side of the equation. So when we reach this line here, we just want to rewrite this as a comment A is equal to A plus B plus C, because this is exactly what this line is doing. So we want to do that. Once we do that, then all you want to do is substitute the values for the variables and do nothing else. We don't want to do multiple things at a time, and if we start trying to do multiple steps at once, we're more likely to get something wrong. That's the whole reason. So all we do is substitute. Next, what do? Follow PEMDAS, cops pops. For most of this, it's just going to be PEMDAS. We're not involving conditional operators and Boolean operators yet. We'll be doing that in the future. This is also called Tracking Problems Part 1. We will be doing tracking problems as well when we're working with if statements, and then again when we're working with something called loops. So this type of problem will come back a few times. All right, so we follow PEMDAS cops pops. That means we should do our parentheses first, and then we can evaluate as normal. So evaluate to a single number, and then you have two options here. I would recommend maybe highlighting or underlining the new value that you have, just so you don't reuse A is equal to 1, maybe you use A is equal to 6. That way you are not gonna just have a silly error by using like A is 1 here, right? A is changed, A is now 6. And then we move on to the next line. Move on to next line, which is repeating steps 1 to 6. All right, so this is the as slow as you can do it, but slow makes less mistakes. All right, B minus equals 1. We just rewrite this like that. We substitute. B is 2. We follow PEMDAS. There's only one thing to follow. B is now 1. And we can move on. Now we got A is 6, B is 1, C is still 3. Right? This is how you do step number 5. I'm reminding myself what the new values are. That way, I will make sure to use the updated values. All right, this and the next one are probably the hardest lines, so let's be very careful. When we say C times equals, we're saying it's C, you take the old value, C, and you multiply it times the entire right-hand side of the equation, like this. Then we can substitute those values. C is 3. A, where's A? I'm going to highlight, A is 6. Be very careful to substitute the correct values. Now that everything's in their number form and not variables, I can follow PEMDAS. So I have to be careful here. I should not do 6 minus 3. That's not following PEMDAS. Inside these parentheses, we do modulus before subtraction. So we do 3 mod 2 first, and we get 1, right? Remainder after 3 divided by 2. Then we follow parentheses, so we should do our subtraction first. Then we can multiply. We get C is 15. So A is now 6, B is now 1, C is 15. If you have to scroll up or you have to change pages or whatever, it might also be helpful just to remember by writing it down again, closer and all in the same spot. A is 6, B is 1, C is 15. I find that helpful sometimes when a problem is longer. Then we do this line. This is now the same as B times exponent, or yes, raised to the power of this. What is this? Well, this is new. First, we're not substituting anything yet, so I'll just write it out. Then we'll talk about what abs is. You can see it's highlighted blue. When we have something that's highlighted blue, that means it's a function, something called a function. So abs is a function for using absolute value. So all this is going to do, this is something called a built-in function. It's going to take whatever is in the center here, whatever the result of this expression is, and it's going to take the absolute value of that result. Okay, so we're still going to follow our steps. We're going to substitute first. A is 6, C is now 15. Oh, I didn't substitute for B here. B, what is B? B is 1. Okay, so I know I'm going to do these parentheses first, but now we have parentheses and parentheses, so that means we'll do the inner parentheses first. So 6 minus 15 is minus 9. It looks like I'm missing a parentheses here. This parentheses here should line up with that one, this one with that one, this one with that one. So a lot of parentheses. All right. Lots of parentheses might look more confusing to you at first. However, I do not think you should neglect them. You just should get used to using these because they're ultimately going to help you not make mistakes, even though it might be confusing to look at multiple parentheses at once. All right, now we can do this inner part. 1 minus minus 9 is 10. Okay. Absolute value of 10, well, it's actually already positive, so it just remains positive. So now B is 1 raised to the 10th power, that's just 1. All right, so B actually didn't change. It was 1, and after all that, it's still 1. All right, I guess we could have known that ahead of time because 1 raised to any power is going to be 1, but that's all right. Now we can do this line here. We're going to rewrite it again because that's our first step. Then we substitute. What's A? Let me look up here. A is 6. Okay. We do parentheses first. So we're going to have 1 divided by 1. Does that mean B doesn't change again? That's correct. So it looks like our answer here should be 6, 1, and 15. Did we get that when we printed? We did. We did it right. So this is how you show your work for these kinds of problems. Look at all these lines we wrote. You should be doing this many lines per line of evaluation if you want to get the problem correct. It's as simple as that. If you do what I do here, you'll probably get it correct. If you skip lines, you'll probably not get it correct. I've been doing this a long time for my students, and the ones that follow instructions for these types of problems are the ones that are consistently getting the points for these. The ones that are ignoring these recommendations are typically going to mess up at some point. You can mess up even if you do follow these lines. Everyone can still accidentally add or multiply something incorrectly, but this helps you catch those mistakes. This helps you make less mistakes. So hopefully I'm very clear about how to do this. I would like everyone to get their points in these problems. Problem 2, we're just going to do one more problem of practice for this video. Yeah, there's nothing really new in here except we're going to try out some more difficult lines here. So now A is 2, B is 3, C is 4. But we're going to do the same process. So we're going to rewrite this. We're going to use our parentheses because we should evaluate this first before adding it to the old value. In this case, plus is commutative and it's not associative, so it doesn't really matter for the parentheses here, but we're gonna do it anyways. It's good practice. Okay, what's C now? C is now 4, so we're substituting values. B is 3, A is 2. We do our exponents first, so 2 raised to the second power is 4. Then we'll do the inner parentheses to get 12. Then we'll do this last part to get 16. For these videos, when I'm doing problems like this, normally in class I would be asking you guys to try it out. So I do recommend at any point pausing the video, try to do the problem for yourself before you see me do it. All right, if you watch me do it, you're not going to be learning as well as if you do it yourself. All right, this line, we start with rewriting it, since most of these are using the shortcuts, the shortcut operators. Then we substitute. C is now 16. B is 3, I believe. All right, we're gonna do the division first. 3 divided by 2 with integer division is 1.5, but we drop the 0.5. And then 16 mod 1, there's no remainder. C is now 0. Did we get 0 before? Yeah, we did. So it looks like we did that first part right. All right, now we're going to change A. This one actually does not have a shortcut assignment operator, just regular assignments. So we can just go straight to substituting. Let's see, what is B? B is 3. C is now 0. Well, here we have parentheses in parentheses again. Specifically, this function's parentheses do count, so that means you should do this function first before we try to use this exponent. So absolute value of 3 minus 0, that's just 3. All right. Notice at no point during this video for either of these problems did I try and do 2 steps at once. We're always just doing one little step at a time. I could do multiple steps at a time, but we're not, because we want to be very careful. And being careful for these problems is how you get them correct. All right, last one. I think we did get that right. Right? A is supposed to be minus 5. We rewrite this. Here the parentheses are really important. Look at all these minus signs. If we are not careful with our distribution, we're likely going to mess some part of this up. Is B still 3? It is. But A is now minus 5. You could write it like this, but I think that looks a little weird, so I'm going to use parentheses here to show that that minus sign is going to distribute. All right, only the substitutions first. And now I do PEMDAS, cops bops. Here we have 2 parentheses. They have the same precedence. There's nothing to evaluate in this one, but we can evaluate that. So even though it's a little silly, I'm gonna do just one at a time. And now I can evaluate these minus signs distributing. So we get 5 minus 3 plus 2. The inner parentheses is now 2 plus 2. That minus sign is now acting like minus 1 times 4, or just 3 minus 4, we get minus 1. There we go. I think we got the correct answer here. A is minus 5, B is minus 1, C is 0. All right, and that's how you do tracking problems.